Hi, today we want to focus on association rule, and the objective of this lecture is to define association rule. We would want to look at the matrix of association rules. We also want to see where association rules are applied, and then lastly we are going to look at the disadvantages of association rule. So what is association rule? This is the data mining technique which tries to identify interesting relationship patterns, correlations, or co-occurrence of data items in a database. The act of using association rules is known as association rule mining. When you are looking at association rules, you are basically trying to look at if-then statements. So let's take for example that in a transaction there was somebody who purchased bread and then purchased milk. If we take a closer look at this, we could then say that if a customer buys bread, then the customer is likely to buy milk also. So if we're going to put this and rephrase it in an association rule, we could then say if customer buys bread, he or she is 93% likely to buy milk. This is the association that we'll be trying to find out. We try to find the patterns using the if-then statements. Association rules consist of two parts, and these two parts are the antecedent and also the consequent. So using our example, let's just try to expand this and combine with the if-then statements. The antecedent is equal to the if part of the if-then statement. It can also be referred to as the left hand, and in our example it is bread. So bread is our antecedent, it is our if, or it is our left hand. And then if we are going to look at the consequence, the then part of the statements is equal to the consequent. It is also, or can also be referred to as the right hand of the statement, and in our scenario, milk becomes the consequent. Association rules are generated by scanning data for patterns which match the if-then statements using metrics to determine the importance of relationships. And these three metrics are support, confidence, and lift. We are going to look at an example for us to then understand how these metrics work. Let's take it and assume that we have a data set of sales in a shop given on a certain day, and the table below shows illustrate the transactions where we have got 5 transactions, and we have got item sets. And in this example that we have there, the number of transactions which we can refer to n are 5. And then if we're going to take, for example, the first transaction, then bread, milk, coke, and diaper is or can be referred to as an item set. Let's dive in and now focus on support. Using our example that we already have, how then can we calculate support? When we are looking at support, we are looking at the frequency of an item. So let's take, for example, we want to get the support of bread, milk. We are then saying we want to see how frequent bread and milk appear together in a transaction database. So In this case, we are then going to go and check all the transactions that we have, the 5, to see how many times or how frequent does bread and milk appear together. So to calculate that, we then say the formula says the frequency bread milk divided by the total transaction, which is n. So if we go to our first transaction, we can see that bread and milk appear together. That becomes 1. Second transaction, bread and milk also appear together. That becomes 2. And then in transaction number 3, we don't have milk. We go to transaction number 4, bread and milk appear together, makes them 3. And transaction number 5, we don't have bread. So the frequency of bread and milk, given that total number of transactions is then 3, divided by the total number of transactions that we have from 1 to 5, which is becomes 5. If we're going to do your math there, then you are going to get a 0.6, which is 60%. So that's the support of bread milk given a data set. Let's take and try to calculate the support of bread alone. So if we're going to check the support of bread alone, we're going to look at the frequency of bread in all the data set that we have. And if we're going to count, we have got transaction number 1, transaction number 2, transaction number 3, transaction number 4. So we have got 4. The count becomes 4, and we divide that by the by n, which is total number of transactions, which is 5. It gives us a 0.8. Let's also do the same for milk. If we're going to count again the frequency of milk in the whole data set, we find that we have got milk 1, 2, and 3. We have got 4, which becomes 4 divided by 5, and we also get an 80% in terms of the support of these item sets. We can also introduce a frequent item set term, and basically when we are looking at an item set, like we have referred in our previous slide, that if you look at transaction number 1, bread, milk, coke, diaper can be referred to as an item set. But what then do we mean when we say frequent item set? Basically, we are looking at an item set which whose support is greater than or equal to the user specified minimum threshold. You will see that when we are going to do look further into the algorithms that are implemented in the association rules, such as the a priori, we then want to look at the frequent item set, items which are have got a support which is greater than the minimum that is specified by a user. Okay. Let's then also look at confidence. What do we mean by confidence? Confidence indicates how often the rule has been found to be true. It can be calculated as follows, given the results that we have from the previous slide. And that is the summary of the result, where we were looking at the support of bread to milk, and we see that its frequency is 3 and its support was 0.6. The bread, its frequency in that whole data set was 4, and its support value there was 0.8. The same was for milk. We could calculate confidence of bread milk as the frequency of bread and milk over the frequency of bread. So we are basically saying, okay, we need to find the confidence that this rule where we are saying bread drives milk, and we then divide that by how often the left or the antecedent occurs in the whole data set, right? Or we can use the other method where we then say support of bread, milk over the support of bread. Basically, these two are almost the same. Okay, so let's take a look at them in detail. The confidence of bread, milk, using the first formula there, where we have a frequency of bread, milk, and if we take from the the results that we calculated there. The frequency of bread and milk is 3, divided by the frequency of bread, and the frequency of bread is 4. We get 0.75 as the frequency. And if we are also going to use the second option formula, where we are going to use the support instead, and according to the results that we have there, the support of that is 0.6 divided by the bread support, which is 0.8. We also get a confidence of 0.75. This is how you would calculate the confidence of a row. Let's look at the last metric, which is the lift. And when we are talking about the lift, it measures the strength of any row. We would want to see how strong the row is. We could calculate this using the formula where we say the lift. To see the lift of the row where bread and milk, would then say support bread, milk over the support of bread multiplied by the support of milk. So in our example there, what we have, we already have the support of bread and milk, which is 0.6 divided by the support of the product of support of bread and support of milk, which is 0.8 and 0.8. If we are going to do the math there, we'll get 0.6 divided by 0.64. It gives us a 0.9375. Or we could use another formula where we use the confidence instead, and we say the confidence of bread and milk over the support of milk. And we, from the previous slide, the confidence that we had there was 0.75 divided by the support of milk, which we have represented there by 0.8. We still get the same result. How then would you interpret lift? Basically, to interpret lift, would want to look at 3 categories of the values of lift. And we are saying if the lift value is closer or equal to 1, what does it mean? It indicates that bread and milk almost always appear together as expected. But from that conclusion itself, there is no rule that we cannot draw a rule involving the 2 events, right? In other words, we can't we can't say that that relationship or the dependence or the correlation or the relation is strong. We would then want to look much on the lift which is greater than 1. That when we get a value that of the lift which is greater than 1, it indicates that bread and milk appear together more than expected. It means to say these are correlated to each other. When the lift is less than 1, it indicates that bread and milk appear together less than expected. In other words, it represents, or is most likely to represent, that these two or these products are most likely to be substitute. That is, they've got negative effects. If one is purchased, the other one is not going to be found in the basket, right? The greater the lift value, the powerful the association. So basically that's the rule, or that's a key point to take when you are then going to interpret the lift. The greater the lift, the more powerful the association value. Where then can we apply association rules? So association rules is an important association rule mining is an important algorithm or technique of data mining that is used most likely has been used for market basket analysis, where suppose in the shop they would want to see how they can improve their sales. They would want to see how they can display their products inside the shelves. It helps in stock management. It helps in sales and promotions. It can also be used in medical data sets, where doctors have been using assertion rule mining to diagnose patients, where we would want to say if the temperature is that, and also there is some vomiting, then most likely it could be this disease or that. So assertion rule is important. Assertion rule mining is an important technique in mining. It has also been used on social medias and recommendation systems, in web mining, server log analysis, where you would then want to look at how a user has been clicking links, following up links, where you would want to determine that whoever is going to click on this product is also going to click on this product using some activities that are logged on the servers. User behavior in terms of whoever likes this politician is also going to like the next politician, or dislike that politician. These are all areas where association rules can be implemented, right? Entertainment in terms of the Netflix way, uh, then the supplier, the product will then recommend what you are supposed to watch at a certain given time, and all these they will increase their sales, also increase their user experience, keep clients to their platforms, and improve in terms of management and decision making. Which algorithms can be used with the association rule mining? Uh, Basically, you could use the a priori algorithm, you could use the client, and the FP growth. We are going to look at these algorithms in their separate sessions. Then the disadvantages, like any other algorithm in data mining, um, association rules also comes with its negatives, right? So it can end up creating a huge number of rules. When we are dealing with a larger data set, the iteration process is too length. And if it is too length and there's a lot of parameters to be considered, it also means that this algorithm can be memory expensive in terms of its calculation. And some of these rules, they end up not having they end up not being of greater importance, right? So this is what we wanted to look at, to define the association rule, to look at its metrics, where it can be implemented and how it can be implemented, why it is important. After this this session, we will then want to then look at the different algorithms in a separate session, and I hope that you have understood the concept of association rule. And remember, before we come to the end of this session, if you are new to this channel, then please kindly click the subscribe button so that you won't miss future uploads and updates to this channel. Right. I'm Ed Light, and I thank you.